All right, guys, today we're going to be talking about variations, okay? So, it says write its situation using algebra to define it. Okay, A varies inversely as the fourth power of t. So you would say A varies inversely as the fourth power of t. There's always a constant k, okay? Inversely means the division piece. Okay, now it says A varies directly as the fourth power t. So that means A equals k t to the fourth. Okay, now it says A varies jointly with t and w. That means A equals k t w. Okay, so again, there's always the constant k. And then inversely means the division, directly means multiplication, and jointly also means multiplication there. So now v varies jointly as h and the square of r. Okay, so v varies jointly, and then you have k, h r squared. Now it says p is inversely proportional to the square root of 1 plus r. So p is k inversely 1 plus r. Now we get to look at some word problems that we'll have to solve these type of equations with, okay? So let's move on. All right, it says a boat travels at a speed of 20 miles per hour in still water. It travels 48 miles upstream and then returns to its starting point in a total of 5 hours. Find the speed of the current. Okay. So the variable is x. Going upstream means going into the current. So it's not helping you, it's hurting you. So that's your speed minus the current. Downstream is with the current, so your speed plus the current speed. Now, if we travel 48 miles up and then return, that's 48 times 2, so 96. So remember, distance equals rate times time. Okay? The big trick here is that we have a total of 5 hours, so it wasn't like 5 hours one way or the other. It's a total of 5 hours, and it's not going to be cut in half because they're different speeds. So we know if we did 48 divided by 20 minus x, because that's the distance. So if you think about this, time equals distance divided by rate. This is the distance you traveled, that's the rate you traveled at, okay? But we have to add the other one as well. Equals a total of 5. So now what we have to do is get the common denominator. So this one I'm going to have to go 20 plus x over 20 plus x. And this one I'm going to have to go 20 minus x over 20 minus x. And then this one, put it over 1, and I'm going to have to do both. And actually what I'm going to do here is the bottom I'm going to make 20 minus x, 20 plus x, because now they're all the same, so I can get rid of it. But the top, it's going to be 400 minus x squared. That's just what these multiplied together are. So here I got to distribute the 48, so I get 48x plus 960 plus 960 minus 48x equals 2000 minus 5x squared. So 48x minus 48x, 960 plus 960, so you get 1920 equals 2000 minus 5x squared. Subtract the 2000, so you'd get negative 80 equals negative 5x squared. Divide by negative 5. You get x squared equals 16. Square root. So you get x equals 4. So the current speed is 4 miles per hour. Okay? Let's take a look at some more. Alright, it says use Hooke's law to solve the given situation. A force of 50 pounds stretches a spring 5 inches. How far will the force of 20 pounds stretch the spring? Okay. And then it says, what force is required to stretch the spring 1.5 inches? So we have a couple work to do. Now, the equation is the distance equals the constant times the force. Okay? So we know that the distance stretched was 5 inches and it was 50 pounds of force. So we know 5 equals K times 50. Divide by 50, you get K equals 1/10. So now our equation we're going to use is distance equals 1/10 F. Okay? So it says, how far will the force of 20 pounds stretch? So distance equals 1/10 times 20. So distance equals 2 inches. So again, we're still using this. But now it says the force required to stretch the distance of 1 point. So we have 1.5 equals 1/10 F. So multiply both sides by 10. You get that the force is 15 pounds. Let's look at some more. All right, it says the power P generated by a wind turbine varies directly as the cube of the wind speed W. So this means P equals K W cubed. Okay? The turbine generates 750 watts of power. So this one is P in a 25 mile per hour wind. So that means this one, W. Find the power it generates in a 40 mile per hour wind. So the first thing we need to do is we need to find this constant. So you would say 750 equals K times 25 to the third. Okay? So 750 equals K times 15,625. Divide. You get that K is 6/125. So now we know P equals 6/125 W to the third. So you get P equals 6/125 times 40 to the third. So calculate that. You get 3,072 miles per hour. Or sorry, not miles per hour. That's the wind. We already have the wind speed. It's watts. I knew that sounded crazy. My fault. All right, let's take a look at another one. A company has found that the daily demand X for its box of chocolates is inversely proportional to the price P. So X equals K over P. Okay? When the price P is $5, the demand is 800 boxes. So that means 800 equals K divided by 5. So 800 times 5. You get K is 4,000. So our equation is X equals 4,000 divided by P. So the price is 6, so you go X equals 4,000 divided by 6. Okay, so the constant of proportionality is 4,000. The amount sold at $6 is, you would sell approximately 667 because you can't sell a part of it, so I rounded up. Okay, 667 boxes. Let's take a look at another one. You and your friend are riding bikes at the same time. You both take the same time to complete the ride. You ride for 10 miles while your friend rides for 12 miles. Your friend has an average speed is in 1.5 miles per hour faster than yours. What are the average speed of you and your friend? Okay, so again, so it says you ride 10, your friend rides 12. Your rate is X. Your friend is X plus 1.5, and they're both the same time. So, again, T equals D divided by R. So your D divided by R is 10 over X. His is 12 over X plus 1.5. But they're equal because the times are the same. So now we got to cross multiply. So you have 10 times X plus 1.5 equals 12 times X. So 10X plus 15 equals 12X. Subtract the 10X. 15X. 15 equals 2X. Divide by 2. You get X equals 7.5 miles per hour. So there's yours, and your friend's is 7.5 plus 1.5, so that would be 9 miles per hour. Okay? Let's take a look at another one. All right, the cost C in dollars of removing P% of an air pollution in the stack of emissions of a utility company is modeled by the equation below. Determine the percent of air pollution in the stack of emissions that can be removed for $680,000. So $680,000 equals 120,000 P divided by 100 minus P. So again, just cross multiply. So you have 680,000 times 100 minus P equals 120,000 P. So multiply that by 100, you go 2 zeros. Then you have 680,000 P equals 120,000 P. Add this over. So you'd get 680 or 68 million equals 800,000 P. Divide by the 800,000. You get P equals 85%. Okay? So let's take a look at another. All right. It says, the simple interest earned by an account varies jointly as the time and the principal. Okay? So the interest varies jointly, so you have K as the time and the principal. Okay? It says a principal of 600 earns $10 interest. So this is P, this is I in 4 months. This is T. How much interest would 900 earn in 6 months? So So time is always done in years though. So this is like our t here is 4 divided by 12, which is 1/3, okay? So when we go to do this, we have 10 equals k times 600, that's the p, times 1/3. Doesn't matter the order you multiply. So you get 10 equals 200k divided by 200. You get k equals 1/20. So for 6 months, now first of all, the time would be 6 divided by 12, which is 1/2. Okay, so, and how much interest would $900 earn? So we're looking for the I. So we have I equals 1/20 times 1/2 times the 900. Okay? So multiply all that out. So you have 1/20 times 1/2 times 900. And you would get your interest is $22.50. Okay? So if you look down, they wanted the constant, so it's 1/20. The constant here is 1/20. And the interest was $22.50. See you guys in class.